7.4 and 7.5 notes. Properties of special parallelograms, trapezoids, and kites. The special parallelograms would be our rhombus, square, and rectangles. Then we're also going to talk about those outliers that would be hanging out over here, our trapezoids and our kites. First, let's talk about rhombus. One of the special features of a rhombus is that the diagonals meet at a 90-degree angle. We call that perpendicular. Remember that a square is also a rhombus, so this is also true for a square. So squares also meet at a 90-degree angle. So anything that's true for a rhombus is also true for a square because their properties overlap. So anything that's true for a rhombus is also true for a square. Something else that's true for a rhombus is that the opposite angles are bisectors of each other. So if the diagonals bisect the opposite angles. So that's also true for a square. So each diagonal bisects a pair of opposite angles. So that's true for a square, and for a square, we know that that's true always and forever. So if it's bisecting a 90-degree angle, what's 90 divided by 2? That's going to be 45 and 45 for a square. That's never going to change because a square always has a 90-degree angle in the corner. A rhombus, on the other hand, this could be any obtuse angle here or any acute angle up at the top because the rhombus is kind of the knocked over square. But for a square, it's going to be 45 and 45 every time. All right, let's take a look. It says the diagonals of a rhombus, A, B, C, D, and they intersect at E, given that BCA is 44 degrees, and AB is supposed to be 9. I'm so sorry, that's a typo. AB is supposed to be 9. Find the indicated measure. So if AB is 9 and this is a rhombus, all the sides of a rhombus are equal, like a square. So that means that BC is also 9. That side length is also 9. How about AC? Well, if this is 7, it's a bisector, so EC is also 7, so AC must be 14. All right, and then the measure of ADC. ADC. So we want this whole measure in this corner. So recall, this is from a while ago, the properties of parallelograms mean that those two angles are supplementary, or 180 degrees. So if this measure is 44, this is going to match it. That's also going to be 44. So that means that total angle is 88. So if we want them to be supplementary, 180 minus 88 gives me a measure of 92. So the measure of angle ADC is 92 degrees, that total. You could cut it in half to get each little, this chunk and this chunk, but you don't need to. They wanted that whole angle measure. Okay, let's try one with our favorite friend, the rectangle. So the rectangle gets all the properties of a parallelogram, plus it's equiangular, so each corner angle is going to be 90 degrees. I know that. So it says the diagonals of a rectangle, EFGH, intersect at I, given that the measure of HFG is 31 degrees, and EG is 17, so I'll try to write that on there. EG is 17. Find the indicated measures. So we want to know what's the measure of FHG. FHG. So we'd like to know this angle measure here. Well, I know that it's not the same as 31 degrees. That would be, the 31 degrees would be the measure of the one that's next to it. Remember, alternate interior angles, so that's congruent to this angle measure right here. But this total corner angle measure is not known, but I do know that a chunk of 90 degrees is 31. So 90 minus 31 gives us 59. So that means that that angle measure is 59 degrees. How about HF? Well, the diagonals of a rectangle are congruent, so HF is also 17. EFH. EFH. Well, we just found that because it's alternate interior angles, it's the same as before, 59 degrees. All right, and then let's look at our most interesting friend, the square. The diagonals of a square intersect at K. So I know that all the sides are congruent. I know all the angles are 45. I know that it intersects at a 90-degree angle. And each corner angle is 45 degrees. These are just knowledge, just stuff I know about squares. Given that MK is 1/2, find the measure of each. PK, well, if this is 1/2, then PK must also be 1/2. PKN, PKN is our intersection, and remember rhombus or square, they intersect at 90 degrees, so the measure of PKN is 90 degrees. And then M and K, that's one of these little chunks, and I know that those are 1/2 and 90, so each of those are 45. All right, let's compare a general trapezoid to an isosceles trapezoid. So the isosceles trapezoid, the isosceles stands for 2 congruent legs. So recall that that's the one that looks like this. So the base angles are the ones that are, they're consecutive along the longer side of the isosceles trapezoid. Those base angles are congruent. These are called legs, and the legs are also congruent. And then the diagonals are also the same length on an isosceles trapezoid. They are also congruent. These 3 things are only true if it's an isosceles trapezoid like this. If it's a regular trapezoid, base angles are not congruent. The legs are not congruent. And the diagonals are not congruent. What we do know is that with a regular general trapezoid, if you look at the base angles of that trapezoid, we do know that that could be 90 degrees and that could be an angle. And we do know that they're supplementary. So remember that consecutive angles of a trapezoid are 180 degrees. So let's take a look at this example. Find the measure of angle K and the measure of angle L. So if this measure, I can see it's parallel and I can see it's congruent. So this is an isosceles trapezoid, which means that if this is 23 degrees, then angle L must also be 23. And then we want the measure of angle K up here. Remember that consecutive angles along a trapezoid are supplementary. So 180 minus 23 gives me 157. So the measure of angle K is 157. All right, our last special figure is a trapezoid. Trapezoids are similar to triangles, where if you had that top of the trapezoid, this mid segment, if it were in the middle or it was a mid segment of the triangle, it has to do with being half of its opposite or its parallel lengths. There's an additional piece when you cut off that trapezoid, you get an additional base length. So first thing we need to know is that the mid segment of a trapezoid is parallel to each of its bases. And then this length in the middle is 1/2 the sum or the addition of the 2 base lengths. So I would do AB plus DC and then cut that in half to get MN. So it's not just 1/2 of one of the lengths, it's half of both of the lengths. So let's try some examples. Find the measure of CD. So one base length is 12, one base length is 36. So 12 plus 36 is 48. And then if we want the measure of CD, we cut that in half. So 48 over 2, 24. So CD is 24. All right, how about this one? This one, I'm missing one of the base lengths, but they gave me the mid-segment length. So what we're going to do, I like to add a variable to the length that I'm looking for, and we're going to follow the pattern. X plus 0.6 divided by 2 is our mid-segment length, 1.8. Sorry. And then we solve. So times 2, x plus 0.6 is 3.6, minus 0.6, and x equals 3. So this length is 3. All right, and then another special figure is the kite. The kite is a quadrilateral, and if a quadrilateral is a kite, then its diagonals are perpendicular. Remember that squares, rhombus, and kites all have perpendicular diagonals. Those are the three figures that have perpendicular at their diagonal center. Another thing that's true is that the kites have exactly one pair of opposite angles, that are congruent. If they had more than one opposite angles congruent, it wouldn't be a kite anymore. Potentially, it would turn into a rectangle if it had lots of opposite angles congruent. So let's try this one. Example number 6, find the value of x is in JF. Well, if this is a kite, which I can see it is, it's got two sets of congruent lengths. That means that those two lengths, I should really use 3 tick marks. Those two lengths are the same size. So 1/10 x minus 1 equals 9. Plus 1, 1/10 x equals 10 times 10. So x equals 100. All right, and then our last example, example number 7, what is the measure of angle L? Well, I can see it's got two sets of congruent lengths. These two opposite angles are not congruent, but this is a kite. So that means that angle L is going to be congruent to angle K, which means I'm going to need to use my knowledge of all 4 angles and the fact that this is a quadrilateral to work backwards. So I know this angle is missing, it's an angle X, but I know that it matches this angle. So I can call both of those angle X if I want to. And I know that this is a quadrilateral, so the sum total of angle measures in a quadrilateral is 360 degrees. So now I can say x plus 130 plus this is, that angle measure is 90 degrees, is 360 total. X and x is 2x, 130 plus 90 is 220, equals 360 minus 220. 2x equals 140 divided by 2, so x equals 70. So angle L equals 70 degrees. Thank you.